Hello, I'm Roberto, and today we'll be discussing heat, thermal energy, and temperature. Enjoy. What is heat? Heat is defined as energy transferred from one body to another as a result in a difference in temperature. It is the result of the flow of energy from a higher body of energy to a lower. The clothing of this firefighter is thick and absorbs the heat of smoke and flames, creating a protective barrier to his skin. Now let's look at 3 types of heat transfer. The first type of heat transfer is conduction, the process in which heat transfers due to direct contact of molecules. An example would be heated seats. A person feels warm as they are sitting in the seat, and the heat is directly transferred to their bodies. Another form of heat transfer is convection, the process in which heat transfers due to up and down movement of molecules. A freezer makes the air cold. The cold air drops down into the lower half where the food is cooled, and as heat rises, it goes into the freezer again, creating a cycle. The third type of heat transfer is radiation. This is the mode of heat which transfers through open space. So, as seen in this photo, the sun is sending its heat through space to the earth, which is why we feel the warmth of it on our skins. Next, we discuss thermal energy. Thermal energy is the energy that is possessed by an object by virtue of the movement of its constituent particles. It is the total internal kinetic energy of an object due to the random motion of its atoms and molecules. It results from the movement of the particles, so it is a type of kinetic energy since it involves motion. Let's look at some examples. Let's look at an example. In A and B, the glasses of chocolate milk have the same amount of liquid in them. However, B has a higher temperature. Those molecules are moving faster in glass B, thus a higher thermal energy. In the glass C and in the jug D, the temperature is the same. However, because there is more molecules in the jug, it is said to have a higher thermal energy. Other examples of this application are in thermal imaging and in geothermal energy. Finally, we discuss temperature. Temperature is the measure of hotness and coldness, and it is expressed in terms of Fahrenheit, Celsius, and Kelvin. Temperature, it indicates the direction in which heat energy will spontaneously flow. It always flows from a body of a higher temperature to one of a lower temperature. The unit Fahrenheit was invented by German physicist Daniel Gabriel Fahrenheit. It is based off of 32 degrees for the freezing point of water and 212 degrees for the boiling point of water. The interval between these two is 180 parts, and it is commonly used in the United States and other U.S. territories. Celsius is a scale based on 0 degrees for the freezing point of water and 100 degrees for the boiling point. It was invented in 1742 by astronomer Anders Celsius, and it is sometimes called centigrade because of the 100-degree interval between the defined points. Being a scale of 0 to 100 has made it used scientifically worldwide and more commonly used wherever the metric system is used, which happens to be most countries besides the United States. Kelvin, which is named after the inventor Lord Kelvin, is an absolute temperature scale that has at its zero absolute zero, the theoretical temperature at which the molecules of a substance have the lowest energy. All molecular activity has ceased. This also makes many calculations and formulas more simplified using this system. The difference between the freezing and boiling points of water is still 100 degrees, just like in the Celsius scale. and it has been adopted as the international standard for scientific temperature measurement. Here we can see how the three temperature scales compare. When using Fahrenheit, 0 to 100 is practical in terms of the average human comfort levels. 100 degrees Fahrenheit is very hot, and anything above that dangerous. And anything below 0 degrees is also dangerous and very cold. Celsius is advantageous because the scale is set from 0 to 100, and it's based off of the water phase change. However, when moving up a degree in Celsius, and Kelvin as well, you also have moved up nearly 2 degrees in Fahrenheit, making it more difficult for precise temperature control. The Kelvin scale, though, has the purpose of only having positive numbers and identifying where the absolute temperature is, where all heat is removed and kinetic motion has ceased. Let's review. Heat is the flow of thermal energy, and the three types of heat are conduction, convection, and radiation. Thermal energy is the kinetic energy of the molecules in the substance. And temperature is the measure of the heat that is transferred. The three types that are common are Fahrenheit, Celsius, and Kelvin. And that was my presentation on heat, thermal energy, and temperature.